Good morning. Chapter 13, Lesson 7 is on page 605 and 606, and it is the last lesson in the book. Congratulations, we've gotten to the end of the book. It says using quadratic equations, and let's see what we can work out. Number 5 says, let me look in the book, the length of a rectangle is 2 centimeters greater than the width, and the area is 80 centimeters squared. Find the length and the width. So the length is 2 more than the width. So let's see if we can come up with the area. And we know that the area is equal to the length times the width. And in our example, it's going to be the width times the width plus 2. And it gives us that the area is equal to 80 centimeters squared. So we have W times W plus 2. Turns out to be 80. Or we have W squared plus 2W is equal to 80. Or one more time, these are zero product properties. W squared plus 2W minus 80 turns out to be equal to 0. And I bet if we think about this for just a minute, the two factors have to have minus 80, and yet they're separated by a plus 2. I bet you're going to come up and say, hey, I know what the two factors are with all this practice we've had. One is W plus 10, and one is W, minus 8. And those have to be 0, so we factor W squared plus 2W minus 80. Well, our zero product property tells us that W plus 10 is equal to 0, or W is equal to negative 10. Our second one says W minus 8 has to be equal to 0, or W in this instance has to be 8. So as we look at our two answers, we're going to discount this negative one automatically, and we're going to toss that out because we can't have negative directions. So if we go back to our problem, the width has to be equal to 8. And lo and behold, the length has to be 8 plus 2, or the length has to be equal to 10. Not so bad. Let's try something a little bit more challenging. Number 17. Oh my God, he's got the box method, the triangle. It's a dirt problem all combined into one. Let's see if we can figure this out. We've got dirt. D is equal to R times T. And let's read the problem on page 606. Let me get the book here. Trains A and B leave the same city at the same time. Train A heads north, and train B heads east. Train B is traveling 5 miles per hour faster than train A. After 2 hours, they are going to be 50 miles apart. Find the speed of each train. Whoa, lots of information for the last lesson in our book. Well, we've got dirt. And it says that after 2 hours, when T is equal to 2, the trains are going to be 50 miles apart. And this is a right triangle because one's headed north and one is headed east. So what we can say is we can figure out the two distances, and we can use the distance with c squared equals a squared plus b squared. And we can say that the distance traveling north is going to be the rate times the time, which is 2r. The distance traveling east is going to be the time 2, and this rate is going to be r plus 5. And we know with our Pythagorean theorem that we can do c squared is equal to a squared plus b squared. And in this instance, the c is the 50. So let's put that all together, and we're going to end up with 2r squared plus 2 times r plus 5 squared has to be equal to 50 squared. Our Pythagorean theorem. This looks like 4r squared plus 2r plus 10 squared, and that's going to be 2500. Well, this looks like 4r squared plus 4r squared plus 40r plus 100 has to be 2500. And all I did was I FOILed 2r plus 10 times 2r plus 10. If we combine like terms, we have 8r squared plus 40r minus 2400 is going to be equal to 0. I'm using my zero product property, and I subtracted 2500 from both sides. 100 take away 2500 is 2400. My God, this problem can't get any worse. Well, I think we can divide everything by 8 if we want to use a factoring. And if we do that, we end up with r squared plus 5r minus 300 turns out to be equal to 0. So we have AC, we have B. A times C is a minus 300. We have B, which is a 5. So we have to come up with factors of a negative 300, and their sum is 5. And I bet you're going to say, God, these are pretty simple. Actually, we've got a plus 20 and a minus 15. And 2 times 15 will give me the 3, and 20 times 15 gives me the 300. So without even using our box, we have our factors. We have, excuse me, r plus 20 times r minus 15. Remember, we could put it up here. We could put r squared. We could put minus the 300. We could place the 20 r and the minus 15r, and we can go through this. We can say r plus 20 and r minus 15. So that just shows that we can use that box again. And the zero product property tells me that those are equal to 0. Well, we're almost done. That tells us that r plus 20 is equal to 0, or r is equal to negative 20. And then r minus 15 has to be equal to 0, or r has to be equal to 15. Well, we're going to look at these things, and we're going to say, you know what, we can discount automatically this r is equal to negative 20, because we can't have it going backwards. That's what that would mean. It would be going backwards. So the rate of the train headed north turns out to be, lo and behold, 15. This is the northbound train. And we find out that the eastbound train has to be r plus 5, or the eastbound train is going at 20 miles per hour. Was it miles per hour? Yeah, 20 miles per hour. So even though the problem looked a lot worse than it was, once we got started, it turned out to be not so bad. Pretty simple, actually. Thanks so much. Thanks for sticking in throughout the whole year. And I think we're done with the textbook. We'll see you all tomorrow.